Hello, I'm Robert Pająk. I come from Krakow in Poland. Today I'm going to talk about creating build pipelines for a Go project. Here is the agenda. First, I will tell a few words about myself. Then I will demonstrate three tools that I used for automating build pipelines for Go project. At the end, I'm going to share with you my subjective conclusions. Before I jump into details, let me introduce myself so I can give you more context to this presentation. On the left side, you can see my family's pandemic photo. Since studies, I've been using mostly Windows, C#, SQL Server, and PowerShell, and stuff connected with Windows. However, 2 years ago, I started to develop in Go. In the beginning, I was creating a new REST API and Q consumer microservices. Now I develop a multi-platform agent. I became to favor Go over C# because of its simplicity, minimalistic approach, design, basically also quick build time, testing package, and lightweight. At last, I try to follow XP values, principles, and practices. I do a lot of automation and use TDD as much as possible, and of course, as much I think it makes sense. In enterprise software development, you usually need to do something more than just Go FMT to format your code or Go test to run unit tests. You want to have some common build pipeline for sake of continuous integration so that the pipeline that you use and your colleagues and the continuous integration server is the same. When we started creating the REST API microservice, a more experienced Go developer created the repository with boilerplate code. It included a build pipeline done via makefiles. After talking with other people inside and outside of our company, I think that I can say that currently Makefile is the de facto standard for automating builds in Go. Without further ado, let me present some simplistic example. For purposes of this presentation, I have created a, a, a little repository which contains a very simply built pipeline created in all of these three tools. The build pipeline is called all and consists of following steps. Clean, which removes files that are creating during the build. It logs which files are removed and which have failed to be removed. FMT formats the code, and the target is implemented in a way so that it can be reused in multiple projects inside your company. And finally, test runs the unit test and generates the HTML code coverage report, even if some test fails. Let me jump to Visual Studio Code. So here is the example for make. The Go code is extremely simple here. We just have an exported function called foo, which returns bar, and a test which expects this foo to return foo. So basically, this test, when I just run Go test, will fail, as you can see. Uh, Now I will show how make from the user perspective. So if I type make and execute, we can see here the all build targets with their comments. If I execute all, it will execute the whole build pipeline. So it executed clean, FMT, and test. So clean have removed the coverage files, then I executed the code formatting, and test has run the test. Even though it failed, it has generated the HTML report. Let's check how it is implemented. So if you type make, the make by convention searches for a file called makefile to find the declaration of the targets. Here is the declaration of the all target. Here is the comment, and here we have declared that it depends on these three other targets. So it will execute them one by one. Clean is implemented just to remove the files which are matching this pattern. Test remembers the exit code here or assigns as a 0. Then it runs go test, assigns the exit to the exit code from this invocation. Then it runs go tool cover to generate the HTML report, and it exits with the value which is assigned here. And in the beginning of this file, we have an include statement, which is a way of reusing some common stuff in the make files. So this file could be shared using Git submodules, subtrees, or even by copy pasting these files between multiple repositories. Let's look at this file. First, we have like some boilerplate common stuff. We are assigning that make should use bash as the shell. The default goal will be help, which is implemented here. And it is a magic target which parses the make targets in all make files and fires the one that have this magical command after the two hashes, and they are being printed. Here we have a definition of a print target, which just prints what is the currently executing target, and finally the reusable FMT target to call GoFMT. Okay, if you want more details regarding make, here's a very good documentation for make with also some explanation, capabilities, very good docs, etc. Problems I had with make. Learning Go, Make, and Bash at the same time was very frustrating for me because I had to learn basically 3 languages at the same time. Especially, I think you can imagine how I felt when I look at example makefile from the probably most popular Go skeleton application, which is here. And here we have some if statements, some shell functions, make, add prefix, some substitutions, and basically a lot of stuff for each statements, force, so a lot of stuff which is a lot of stuff from make. Moreover, because of problems connected using Go, Make, and Bash on Windows, I started to develop on Ubuntu. I also know that SREs are writing Go apps instead of Bash scripts for reason like compatibility, so that the Go runs in the same way on each environment, but for Bash scripts you often rely on other programs like set, less, wget, curl, and you have often no control on its versions. A few months passed, and after learning the most important stuff in Go, Bash, and Make, I decided to take a look at Mage to check if it would solve some of my concerns and if it will be easier for me if I used it from the beginning. I wanted to also to check if it will be maybe easier for other newcomers. What about Mage? Mage is a make rake-like build tool using Go. You write just Go functions and Make automatically uses them as makefile runnable targets. What does it mean? Again, demo time. Going back to Visual Studio Code, I will change the folder. So right now we are in the Mage folder. And before I go into details, how it is implemented, let me show it from the user perspective. Here I'm taking advantage of Go modules and I'm using Mage like as a very small application. So I have a really small main function which executes mage here. So to execute mage, I just use go run mage go. We have so here we have description of all targets. So let me now execute the pipeline. So I have an information that go test has failed with exit code 1 without any output. Usually to have output when running mage, you run it as using verbose. Sorry, typo here. I should put the v flag here. So here you can see a similar output that we had in make. We are running target all, we are running dependency clean, the files have been removed, and we are running dependencies. First we are using then we are running the FMT, the test has failed, and we have the error status here. So let's take a look at this implementation. Mage requires to put a magical mage build tag at the beginning, and then we have the implementation of all target. Here we declare that it's dependent on these three other targets. Here is the implementation of the clean target. So here we have the deletion of the files matching this pattern written in Go. So whenever we fail to remove a file, we remember the last error and we print that it failed to remove, and if it succeeded, we print it as well. When we are running the test target, we are running both tools, GoTest and GoTool, and we return the error of any of these commands if it failed. And in this, here is a magical command to import the targets from this package. So this package could be even another repository. So it could so we can have common targets reused across the company for multiple Go projects. So this is how it could be implemented, this repository. Just a really small target FMT which just runs Go FMT. If you want to know more about Mage or learn how to use it, I highly encourage you to go through their web page, even see their video, their demo, and take a look how it is working, how the dependencies are working, and basically read all of this stuff. Okay, let me go back to the presentation. Now, problems that I had with Mage. Basically, my problem was that in general, Mage is magical. It means that the target's discovery records build tags and Mage generates Go application based on it, and it makes debugging very hard. Also, the build tags causes problems for VS Code. I have no IntelliSense out of the box. If you have multiple packages in one folder, then Go please, which is the language server, also gets crazy. The magical import command when using targets from other packages is also quite hacky for me. Initially, when I implemented the dependencies, it occurred that they were running in parallel by default, and the output could be mixed up. Like the sending, like logging the output is not synchronized. It's not something that Mage supports. Additionally, the number of methods in the sh package here for executing a binary, which you can see here, overwhelmed me. This API, I think it's that generally not only this package, but generally Mage has quite big API surface. And I felt that, at least for me, something is wrong. Maybe it could be done easier, simpler, more approachable. It took me more than a year to come up with something. In parallel, I was developing a GitHub project template for Go application, which probably helped me because I had a lot of time to think. So I'm also a maintainer of a Golang template seed. Right now it uses Make for build automation, but at some point it was also using Mage. Uh, so I wanted to create something that feels more idiomatic for me, something that resembles Go, its tools, standard library, and basically philosophy or values, principles. I wanted something simple to use and very minimalistic. I wanted also it to feel familiar with other stuff in Go. So after a few long nights, I thought that I want I thought that tasks should look like unit tests. The API should be similar, and registering the task should be done similar to register an HTTP handler, and parsing args should be leveraging the flag package. Let me show you how the build pipeline would look like when using TaskFlow, which I created. So again, I'm back in VS Code. I will change the folder to TaskFlow, and before uh, before going to details, let me just show it from the user perspective. Here we have similar a little we have the application, the main function which I'm going to execute from which I'm going to execute task flow in build folder. So we'll just run go run build, and I have information that no task provided, usage, flags, and which tasks are available. So I'm going to run all. And run, right now when I'm running the all pipeline, I see only that task test has failed. So when using just like without verbose mode, we have only in the output dependency which or the task which has failed, which is a similar output, and basically also the formatting here is mimicking the formatting from the testing package. So it could be similar and more familiar. So we have the information how much it executed, that it failed, and exit status 1. If we use the verbose mode, it will uh, it will show the output of each task and the execution time of each task. Let me show now how it's implemented. So the implementation is here in a single file. There's no build tags. Basically, TaskFlow is working like as a library. So you create a TaskFlow struct. Uh, if you want, you can change the output or the verbose. The default output is stdout, as far as I remember, and we are registering the task using the must register or register function. And we are registering task in a way that we are just setting the task struct, which defines the name of the task, the description, and the command which will be run when this task will be executed. So, and when we want to, and there's also a dependencies field which you can use to set the dependencies. So here is the all target or the all task, which basically is the build pipeline, and it depends on clean, FMT, and test. The other tasks are registered here. So if we go to task clean, we have the similar implementation which we have seen in the Mage. However, the error reporting is done using a TF fatal F functions and error F functions, so it looks like it is like the same API like you use in unit tests. Thanks to it, you can even use tools like Testify to make some assertions. And you also use logf to log stuff, like in testing package. So if you use the log function, the stuff will be put to output only if when there's no verbose mode, only if some task has failed, and if there's verbose mode, then it will be just printed out of the way, like it will be streamed just like for testing package. Here is the implementation of the test task. So again, name description, and here uh, we have a CMD function, which basically only returns the exec command. So there's only one, or there are only two like helper functions to use to execute other programs. So if you want to change the command, add some environmental variables, you just get the exec command and you tweak it. But if you need no more thing than that, then you just run them. Reusing other packages is it's probably even simpler than in Mage. You just import something and you register it. So here we have the implementation of the task SMT, and there is another helper function exec which returns uh, the implementation of a command which only executes one single process, which is the most common use case in build pipelines. Uh, okay, it went quite quick, probably too quick, and one of the advantages for TaskFlow is that it's very easy to uh, run unit tests or debug. So if you want, you can just click a breakpoint here, just adds like arc to all, for example, put a breakpoint, run, and you have a debugger here. You can also run a unit test by simply new file, main test go. TaskFlow also has a struct called runner, which you can use in your unit test to test and execute one concrete target. So if you run, so you can run, for instance, our task clean command, and we can check if result got, if it passed, or if failed, then we can print that, that fatal F, it failed, or just fail now. So we can put a breakpoint here. It was clean or test clean. And again, if we debug this test, we can very easily just debug one concrete target. without making a lot of changes. If you want more details regarding task flow, I encourage you to look at the repository and at the documentation here uh, in Godot or package GoDev right now. And there's an example. Uh, you can even go to source code because it's very easy because it's just a little library. And time for some conclusions, at least from my perspective. Make is very powerful and it's more concise than I would say more both Taskflow and Mage. It is language agnostic. You can use it not only for Go projects. And if you have something complex, remember that you can always create a little run. You can always write a little Go program and run it from uh, from Make. You do not have to use Bash for everything. I still use Make at work, and not only for Go repositories, but also for non-Go repositories. Stuff like automating setup of local Kubernetes cluster, protobuf validations, and I do not state that Make is bad. I think it's just complex, probably more complex than Go, and it might be hard for newcomers on someone who does not know Make already. What about Mage? It requires only Go. It has a community. It has, according to GitHub, 50 contributors. It has more than 2,000 stars, which is pretty big amount. And I know that it is used in enterprises, and I guess that probably most devs are okay with its design. What about Taskflow? It also requires only Go. It is created as a library instead of a framework tool. And it was created in a philosophy that less is more, and it is an experiment to create something easier, simpler, more approachable. And I hope that every Go developer can learn it and probably in less than an hour. Uh, Yet it is still powerful and something that can scale. It should be very easy to extend its functionalities, create common build tasks or even pipelines, and yeah, debugging is also easy and creating tests. What are my plans? Basically, I'm open and I very would love to hear your feedback and do changes according to the feedback. I'm planning to add unit tests and refactor the Taskflow main function to execute Taskflow. And I also think of adding like an option to output the dependency tree so we could see something like that. So we could use it with GraphViz, for example, and if someone will have a complex build pipeline, he could see all of the dependencies and how they are related. I would love to get feedback from you, both regarding this presentation, if you liked it or not, and also regarding Taskflow. I think that Taskflow is, if you think that Taskflow is worth maintaining or something should be changed, you want to try it, or maybe you think it's even bad and harmful that I should archive it, remove it, please don't hesitate to tell me and discuss anything with me. I'm really open, I'm an open person, and I think that telling that something is bad is basically okay. Uh, I think that it's just important to get the feedback to make something better. And I encourage you to take a look at examples and docs yourself. Please compare it whatever you use and give me feedback. Once again, please, please, please. Here are the hyperlinks and contact information how to contact me. And thank you very much for your time and attentions, and I'm open to any questions. Thank you.